How's it going today? Today I've got a tutorial for you with using Inventor Assemblies to create a VEX robot and how we can take a brain and a brain flange and put them onto a robot. So let's jump on in. There are a few new things in this tutorial, specifically how we use tangent constraints and just some more funky ways we can line things up. So let's jump on in. I've got a chassis here. Everything is in place. I want my brain to kind of fit right on in that area. I've got my brain and my brain mounting flange just in my model space here. So for me, what I always tell my students, the best way to put on a brain, and this is the first method, the best way to put on a brain is to use the mounting flange here. So first off, let's get our mounting flange put where we want it to go. And that's a simple procedure. We're going to use a mate, a flush, and then a tangent constraint. So let's first get that mate. Let's get this put down onto our surface there. To do that, we will select the top of the surface we want, and then we'll select this bottom face here. Notice how there's a bunch of interior geometry in here. We just want this piece right there. Apply. Now I want it facing the other direction, so I can use a flush to kind of flip it around for me. Let's grab a flush. We're going to grab one of these faces here, these interior holes, because those will line up nicely with our squares. Grabbing these sides will not do much for us here. So let's grab that hole, and then we'll grab this piece there. And notice how not only does it flip it around, but if we look at it from the top view here, top view, sorry, we can see that it constrains it along those holes where you would line it up, and nice and side to side there too. So let's bring it this way. So now we need to prevent this thing from moving side to side, don't we? Now the problem we're having is that if I use this face here, let me show you what I mean here. Let me flip around. If I use this face here and this face there and make them flush, you'll notice that these holes do not line up, which isn't helping us in the slightest there. So what we're going to do is we're going to use a tangent constraint. Now this is a new constraint for us. I'll show you what I mean. We're going to open up our constraint window here, and we're going to first, before we do anything else, select tangent constraint. That's right up here in the type. Tangent constraint. Now the problem is if you don't select it first, it's going to change your selections and stuff after you have everything selected. So it's always a good idea, always click the type of constraint you want first. So let's get our constraint panel open, select tangent constraint, and what I'm going to do is we want to select a face and then a line. So, or specifically a circle, right? Tangent geometry is when a circle lines up with something only on one point. So, grab my circle, grab that line there, or actually let's grab this one all the way inside of here, like that, and then it lines them up. Now you can do a lot of research on tangents and stuff and how they work. They're quite interesting. However, in this, it's just important to know that when we line something up tangent to a circle, it only ever touches that circle in one spot. And that, for us, with these two other mates, allows us to keep this in place there. So, let's get so we have our flange already stuck on here. Let's get our brain put onto that flange there. Now, if we look at the edge of this brain flange, it's drafted. Or basically, these lines here aren't totally straight. So if I zoom in on this, you can see that this line and that line are kind of at an angle compared to this line there, right? So that, I mean, this is what VEX does, so they have parts released from the mold and stuff just fine, but it makes it really tough for us to put these constraints on here. first and foremost, let's get these holes lined up here. So what I'm going to do is I'm going to grab this circle, or this one works too. However, you want to stay away from using this in here. If you ever need to select one of these, grab this outside cylinder, which you know is a perfect square and you know is lined up. So I'm going to grab this, and grab effectively that axis, and this axis, and apply. Now let's change my solution so it turns it around. Apply. There we go. So you can see we're able to spin around here. And I just want to make sure that we are good. We're not contacting there. Great. So let's do another constraint. This is very similar to how we mount a motor to a flat bearing, right? Let's grab a constraint there. Mate that axis with this axis. Apply. Oop. Apply. There you go. Good. Now we're just translating forward and backwards. So when we put brains together, we notice that it first wants to contact this point there. So that's what we're going to use. We're going to grab this face, and we're going to grab and kind of crane our view here using our view cube, clicking and dragging, and then this face. Now, this is where you want to zoom in, right? We don't want a line. We want this whole face. Apply, and we'll put a mate constraint there. Now you can see we're on here. Now, in the real world, this may not work so well because your brain's hanging over, but we're going to call it good for now. So, that is one way to put a brain onto a chassis and using a brain flange. I find that to be the simplest way, and that's how I encourage my students to put their brains onto their robots. So, there's other methods where you can use the bottom holes and tanners and stuff, but we won't quite get into that today. So that's what I got for you. As always, let me know if you have any questions. I will certainly help you out. Thank you for watching this, and I will see you in the next one.